Okay, so just a continuation off of what we did last video. This is a remember from previous stuff. We did a test statistic. This was our Z star. Okay, we were looking at the statistic minus the parameter divided by the standard deviation of the statistic. All right, so we're going to do something similar, but again, this time we have two proportions. So the first thing we need to do is we need to have the combination of our two proportions. Okay, so the numerator is we're going to count the number of successes and add them. Okay, and then we're going to divide it by both ends, meaning I want both of the sample size. So if P1 had a sample size of 400 and then the P2 had a sample size of 500, this one would be 900. Okay, so this is our pooled, this is combined, that's the C, and that just means we're going to be adding sample proportion in our standard error. Okay, so then what we have for our two sample, okay, so our Z star is going to be equal to P1 minus P hat 2. So we're going to take our two proportions, subtract them, subtract it from 0, and then we're going to have 1 plus, P hat C, 1 minus P hat C over N1 plus P hat C, again, 1 minus P hat C divided by N2. And that's in the square root. Okay, so let's look at an example. I'll write it down real quick and then we can get. All right, so we're going to continue on with our hearing loss question. Just put some key information down to you. 1988 to 1994, 3,000 teenagers were randomly selected. P1, so their proportion is 0.15. 2005, 2006, our sample size is 1,800 students. Their P hat 2 is 0.195. And then we're asked, do these data give convincing evidence that the proportion of all teens with hearing loss has increased? And then it says, between the two studies, Apple introduces the iPod. If the results of the test are statistically significant, can we blame iPods for the increased hearing loss in teenagers? Okay, so first thing we got to do is we got to do our four conditions. So independent, one teenager's hearing loss won't affect the other. We got random, and that was stated in our other narrative that this is just a continuation on. 10%. So since this one's got two different sample sizes, so I'm going to go like this: 3,000 is less than 10% of all teenagers in the US, and 1800 is less than or equal to 10% of all teenagers in the US. Okay, so there's my three conditions. The long one, so we've got 3,000 times by 0.15 is less than or equal to 10. So that one's 450. The other one's 3,000 times by 0.85, which would then be 2555. And then I have 1,800. And then this one was 0.195. So this would be 351 is less than or equal to 10. So that one's true. And then just so I don't make sure I don't run off the camera, we got 1,800, and this one was 0.805, and that gave us 1,449, which is less than or equal to 10. So all our conditions have been met. Okay. Now we already have that one from our previous paper. Okay, so then we're going to have HA, or alternative hypothesis, P1 minus P2 is greater than or equal to 0. So is there an increase? Okay. So we need to do our combined. So how many successes we had? Well, if we go back and use our numbers here, I know that's 450 and I had 351. So I'm going to go with 450 plus 351, and then I'm going to divide that by 3,000 plus 1,800. And so that gave us 801 over 4,800, and that was 0.1669. So there's my pooled. So next, what I'm going to do is I'm going to do my Z, which would be 0.15 minus 0.195 minus 0, because those are my statistics. That's my parameter, because that's where the 0 came from, was up in here, because that's my parameter. So then I'm going to go with 0.169, because that's my pooled, and then the opposite of that is 0.8331. The first sample size was 3,000 plus, and then this number is the same thing as the other one, but this time I'm going to divide it by 1,800. So let me go like that, and then so I did it like this. I'll scoot that over. How about I just bring it down? Would that be easier? There. So now you can see that. All right. Now, what does that mean for us? Well, if you go look this up, and we can also use our second distribution, normal CDF, -1 e to 99, -4.0477. So what does this number right here mean for us? Well, that means that our p-value 8, 7. That's basically 0. Okay. So, since that's basically 0 for us, if we were to try and think of it like this, right? So, we would like reject, but we're not quite there yet. All right. So, we have convincing evidence that the proportion of all teenagers, because that's what the narrative said, with hearing loss has increased from 1988 to 1994 to 2005 to 2006. Okay? And then, can we blame iPods? Nope. Because there are other factors. Okay? Because in the early 90s, you had Sony Walkman, right? And so would we blame the Sony Walkman for the 1988 to 1994? Okay, you got jet planes, you've got other noise factors that are going to come into play. So you can't just blame iPods, even though everybody would like to and get money. Alrighty, we're going to get the next video going so you can finish it up. We'll see you in a couple minutes.